Right, cybersecurity, everybody knows everything that always gets the headlines. Malicious and planned, sabotage, physical attack, hacking, terrorism, theft. And then we say, what about natural threats from IT? Our end of this is based around the fact we are the front end of the security and not the back end, which is what you've been listening to probably most of today. So you will see some solutions from us which are right and wrong. As we say, it's an unpredictable world. Sadly, I was at Lehman Brothers when it crashed, and they still have most of my tools left with the receivers who wouldn't let me take them out of the building, which is rather nice. Obviously, we have earthquakes, snow from Heathrow, where we grind to a halt in about 1.5 inches of snow. Flooding, which unfortunately seems to be coming more and more. We won't go into football, thank you, because my team's not doing very well at all, but there you go. And we all have IT equipment and IT users who want us to get equipment to work, whatever. As you can see, this says just reboot it and it should be fine. Unfortunately, this was actually in a factory in Italy, and that wiped out their production for 2 months. So, right, physical data center threats. Well, we should all know most of them anyway. So we've got fire, extinguishing water, corrosive gases, power failure, heat development, vandalism, unauthorized access, electromagnetic interference, dust, explosions, either terrorist-wise or naturally, and debris. Now, if you think about a lot of those, you think, nah, that's not going to happen. But in reality, a majority of them do happen. If you think about a lot of inherent, shall we say, data centers are spaces that you've been given, not necessarily spaces that you would like to be as good as they could be. So, the fact of the matter is, all these options here can actually affect you without actually being inside a DC at all. Now, as an organisation, being primarily German-owned, we look to a standard which is basically BSEN 1047-2. It is the best practiced environmental standard for IT equipment in hardware. Okay? Now, in the UK, we adopted the European standard, but we still don't use it as much as we should. So, this gives you practiced protection against all of these items as a collective standard, not just one individual element. Now, we also looked at the fact of downtime and downtime costs and the risks of consequences. We went to the insurance companies and asked them what they thought or what they could produce from their records were the hourly cost and the loss. To manufacturing, they say it's 28,000 because primarily if something goes wrong in manufacturing, there are other pieces of equipment that can easily be replaced. Transportation, 90,000. I suppose that's a reasonable amount. Catalogue sales, if your IT equipment went down, 90,000. Home shopping, 113,000. Media, pay-per-view, I was quite interested in that because that's quite a big chunk. 1.1, well, it's 1,100,000, which is a big chunk. Banking, 2.5 million, should it go down, IT equipment. Financial credit card, 2.6. Brokerage, I find that a little bit hard to believe, but then I'm not into brokerage, so I don't know. So it's an interesting fact that lots of finance, effectively, can be lost through your IT downtime. My colleague seems to have done me a non-interesting slide, but I'll move along with it anyway. He's saying most victims know who the perpetrator is. In this instance, it's not necessarily what's inside the data center that causes the threat. It could well be in the office. So, what we have, types of threats. The primary ones, which are in any building, if you think about it, are fire, water, and gas and smoke. Now, what this is trying to show you is your DC is next door to all your little friends, colleagues, whatever, who are tapping away, doing their normal things, possibly playing silly games with their feet on a pipe, perhaps. I was actually in the RAC building in Bradley Stoke in Bristol, and their main incoming coolant pipe for an outside condensing plant, somewhere in the region of about 650 mil pipe. The window cleaner was actually stood on it cleaning the windows when the pipe snapped. So you then had in the data center 65,000 litres of coolant. So it's easily done. Fire, that can easily be generated. By utilising a Rittal security room, it gives you protection against all of these and forms a barrier, both stopping things from coming from without in and in outwards. Now, what we'll show you. We have some solutions based around physical IT security. We go through certain criteria. In the rest of Europe, there is contract and liability legislation. Now, UK, we don't tend to have it as detailed or as difficult. If you're in Germany and you are a user of an item in a building or an organisation, you are as responsible as the owner should something go wrong. We recently had a case of a company that's very close to our headquarters. We're based in the Westerwald, and the gentleman there was seen to be negligent for not telling his employer that there was a major fault, and effectively there could easily be a fire in the building. There was a fire. Sadly, one person lost his life. And because this gentleman hadn't informed his boss, even though he knew about it, he actually got 2 years imprisonment. His boss got 5 years imprisonment. Our legislation doesn't go as far as that, but we are beginning to catch up. Now, Rittal as an organisation is a member of ESSA, which is the European Security Suppliers Association. What that means effectively is that we, a group of other security suppliers, your Chubbs and people like that, got together and said that we wanted to produce products that had a quality assurance. And the ECBS accreditation was brought forward. That's the European Certification Board standard. Any product that has that has an independent liability bond. It means that we're audited during the procurement phase. We're audited during construction in the factory phase. We're audited in construction on-site phase. And we're audited in the service phase. Now, that €50 million liability bond, if we ever lose it, we lose that on every product that we have with that accreditation. So it's a major thing for us. So quality is the assurance. What we have here, we have looked at Enclosures. Most people are given space, as I've said, in which they have a data center. It may not be a space that's any good. It may be a space that's been given to them as the only available space. But we still work within the criteria of our standards to try and achieve the best possible environmental practice. We have such a thing as the micro DC. This is an enclosure which has 15 U space, has air conditioning, and can have fire suppression internally, and will withstand 1,050 degrees C fire externally without rising internally by 85 degrees C or 50 degrees relative humidity. IT.
So on that, so I see the air conditioning units on the outside.
Yes, it's a sealed loop.
In a fire, does that not?
No. Basically what you have, and it's a very good question. If you do have any questions, then please ask. No, thank you. Effectively what you have is an air conditioning pole on the top. You have a tube, which basically is a heat exchanging pipe that runs through into the safe and back out, and you have a fan inside which is blowing the cold air, well, blowing air over the cold pipe and then taking it back as a loop. They have a thing called a Roxtec module. Do any of you know what a Roxtec module is? Okay, if oil rig technology, if you're on an oil rig, there is nowhere to go if there's a fire. So an oil rig is broken down into zones. It can be 8, it can be 16, it can be 10. It's always multiples, basically. And what they do there, they put a firewall in between each section. But you still have to run services through each section. So they go through a controlled cable duct. And the controlled cable duct is through a module. Each pipe or cable goes through an individual module, which will effectively, in the event of fire, it has an intumescent base. You know what an intumescent base is, hopefully? No? Okay. Intumescent means effectively that its natural property is that under fire and duress, it will absorb heat and expand, therefore closing off any gaps and sealing that unit off. So if you had a major fire, we'll say a 450, 500 degrees C, which is a standard car petrol fuel goes up at around about 400 degrees C. Yeah. This thing absorbs the heat, expands, chops off the cables so that nothing can go through the cables or through the pipes. And that's what they use on oil rigs. We use that same technology on our safes and our containers and our modular rooms, which we'll go through. Okay, what happens? The cable is then, basically you have a module which you can break in half. You peel it out so that it's just tight fit around the cable or the pipe, and it's fitted under compression. We go a stage further because we don't want that to work, because if it works, then you have got a major incident on you. So what we do is we then cover that with a fire paste, which does exactly the same. It expands, but that will take up any localized contamination. So if the fire's not right on it, but you've got smoke and acrid gases, that seals the unit off. And that's how this thing works. So if you have a pipe or a tube going through, you know you have the big fire suppression pipes with the suppression in, you've got 200 bar of pressure probably running through a pipe, well, 100 mil across maybe a bit bigger. These things will wrap around one of those and crush it. So it's quite a stringent test. So we have a miniature solution which effectively you get 15 US space in. We have a modular solution, which is this one, we can see again here. And the beauty of this solution is it actually complies to SEAP. It's a SEAP registered product. SEAP being the Security Evaluation Advisory Panel of the Government and Military UK. So this effectively wraps around an existing rack. It has the ability to take in air conditioning, but it also has the ability to have high density cooling solutions incorporated into the safe as well. So we were talking earlier, before some of you arrived, about water solutions and people getting a bit twitchy about water in the computer room. We actually do a high density cooling solution, which our friends at HP mirror exactly what we do because it's ours anyway, but there we go, which is water based. So you have chilled water going into an enclosure, fans blow the cold air onto your servers. The server's motion is to drag that cold air through the servers, and when the cold air gets to the back, it's then sucked back out again, and it just goes through the loop again. Now we incorporate free cooling with our high density cooling solution. So you have free cooling in between the return and the chiller. So water's come out the system, hot, goes to free cooling. If there's natural cold air like there is out there today, it takes a percentage of that heat away before it goes to the chiller, where it's cooled down again and just goes back in on the loop. So we're capable of cooling 60 kilowatts of cooling capacity per unit. We can do multiples of this unit, so we can bathe them together. So the idea is modularity. We've looked at lots of solutions. Just to name a couple, we've looked at Eurobond, we've looked at Kingspan, Modusec, lots of room solutions whereby you haven't got a designated space and you're going to put, to all intents and purposes, a box inside a box. So you have a building structure which may not be up to scratch. You could then put in one of our structures to bring it up to the level of the BSEN 1047-2 standard. So it gives you protection against all those things that we're talking about. Now, this is exactly the same solution. This is a SEAP level 3. We do a room solution, which I can show you in a minute, which is a level 2 SEAP. We also now do a containerized solution, which is giving you PUE of less than 1.2, as it shows. We've got some video clips, which are probably better than listening to me drone on. If you look at the top one, this is the modular safe being installed around a live rack. The reason this has a high SEAP rating is that all the fixings are actually internal, not external. So you don't have seams or anything on the outside. bang, done. So you have a high security enclosure wrapped around a rack. Now the beauty of this is, as we've already said, they're energy efficient, climate control concept, up to 30 kilowatts. On this one, it's now up to 60 kilowatts. This is a slightly older slide. You have your extension options are that you can add another module to it and just keep building away. It's cost efficient because we can take it back down, and if you don't use it today, we'll put it somewhere else and put it back up again in a different configuration and use it for tomorrow. Short installation times, as you've seen, it's relatively quick, and not quite as quick as it shows on the video clip, I might say. But the beauty of this is that we've looked at the solutions. If you have huge DCs, you spend an awful lot of money powering them up, which then generates heat, and then you spend an awful lot of money cooling them down. If the enclosures are more around what you're actually using, then it's going to be more efficient. It has to be more efficient. You're not having to cool an open space. It's like having one rack in a room this size and trying to cool the whole room just for one rack. This is a more efficient way of looking at things.
That would also mean you could probably have it in the same office as people are working.
Yes.
It doesn't mean that the office has got to be cold.
That's exactly. The beauty of this is as well, you have to excuse the music. This is trying to show you the modular approach to rooms that we take. So what we just looked at a minute ago was the safe. This is effectively the same, but on a slightly bigger scale. Now the only difference with this is the fact, and everything we do, is all our products are self-supporting. If you go down the routes of your Eurobond, your Kingspan, Modular, things like that, their enclosures will always need an existing ceiling, and then they wire to that ceiling to hold the ceiling up. Ours don't. Everything is self-supporting. So if you were in a building which was not your own, you could actually build this room in there without the landlord's permission, effectively, because you're not doing anything other than putting a glorified cupboard in, but a very high spec cupboard. That's enough of that. We'll move on, because that one's... It will go. Okay. Hang on, I may have gone too far. No, I haven't. Right. What we also like the idea of is, just to give you an example, is that the solution could be used anywhere. You're not designated and tied down to a computer room or a data center, a comms room or anything of that nature. What you see here is a room that I was involved in. It's actually, do any of you know Stepney Green Station in the East End? Yeah, thank you very much. Okay, Stepney Green, I did not believe until I went down there how bad it is from the road above. The road leaks to such an extent that if there's a rainstorm outside, you do know on the underground, because actually you get wetter inside than you do out.
That's not the only underground station.
Probably not, but Stepney Green, I have to say, is the only time I've ever seen one of my colleagues with a brolly underground. But anyway, we assembled an 18 square metre security room in 6 days. The reason for those 6 days, the underground have this wonderful working practice whereby you may only work from the hours of midnight until 4 o'clock in the morning. And the only reason they do that is because that's the only time that they will officially turn off power to the main lines. TfL, as we know, is going through some major changes, primarily through the fact of power source. One of the issues, which I have to say, I do giggle at it, but it's a very serious matter, is the fact, if you think about it, they supply their own mainline power, or get mainline power supplied to the main line, but the switches and the signals are run from a standard source. Now, power in London, as we all know, is, I'll have to excuse my language, rocking horse manure. If you want excess power, it's difficult to get. Now, if you can imagine, our Olympics are going to be with us shortly. If we had a power cut, the trains would be thundering down through the stations, but they wouldn't be getting any signals, and they wouldn't be being told to stop. There's a program going through currently where 234 of the stations have to have a signalling upgrade. This is one of those. There is a servers going inside along with a UPS that, should main power go down, then this will kick in and you will get signals and all the rest of it, and it will switch the track around so you can actually use it. So we build these in all sorts of different places. Interesting conditions is a slight understatement. Unfortunately, I had to bring over a German architect just to give you a little story. Who's a very, very pretty lady. She came across and we decided to go for breakfast. Well, this part of London in the war was rather heavily bombed. And we walked into a cafe that had Winston Churchill doing that to begin with. And then there were pictures of German bombers sort of smashed to pieces on the walls and other rather polite comments in the cafe, to which we had to walk straight back out again. But anyway, yeah, so, I mean, we're actually surprisingly one of only 2 manufacturers currently capable of offering an 18.6E room, which means 180 minutes fire, 60 minutes to the best practice standard. And we are one of only 1 current company that has Section 12 compliance, which is basically being able to install an modular IT environment on any underground station. Now, my favourite bit. What you see here, ignore even the competition trying to blow us away. It's my colleague trying to be jocular, I'm afraid, and he's not. CAP, as I said earlier, is a security evaluation test. Part of that test criteria is you have to have a hand attack test at the PSDB which is now HOSDB, which stands for Home Office Scientific Data Branch. At Horsham, they carried out hand attack. This is actually at RAS Spade Adam in Cumbria. What you have is a concrete pad in the middle of a great big forest, and they carry out an explosive test on it. There were actually 4 tests on this room. This is a 400 kilogram charge. What you see in the black ampule is actually Formula 1 racing car fuel. It's 1.5 times more explosive than TNT, but you've got to give it a kick. So what's in the neck? So you've got fuel in here, which is equivalent to 400 kilogram bomb, which is the same size as the bomb that wiped out the centre of Manchester. And in the neck is American P3 plastic explosive. So let's just run it if I can find the mouse. Now, if you saw that, there was a double flash. You'll see it again at the end. If you look, there's a double flash, which is the plastic to begin with, and then the major charge. I love this. If you look, all this technology that you've just seen in place working, and what do they measure it with? A broom handle. Technology at its best, isn't it? Let's be honest. Eh? Brilliant. I was actually there, and what you see at the background, fir trees, they're 30 metres apart. Okay. Now, being an idiot as I am, and coming from the West Country, so I've got an excuse, I was actually I was allowed to go half a mile away, and they put me in a Dunlop man suit, you know, the old rubber rings, and then the big tethers, about so big, tethered me down to the top of a building, flat roof, single story, right in the middle, all the goals, protection, all the rest of it. And then what they do is they sound the alarm to say they're clearing the pad, and then they drive away. And I knew I'd made a mistake because the guys are going to do it. I've got in the Land Rover, and they drive over the hill behind me. So I know I've dropped a clanger. So the next minute, they do the siren to say they're going to blow the explosive up, but they miss the word 5 because it sounds like fire. So you have your 10, 9, 8, 7, 6, space, 4, 3, 2, 1. Then you hear fire. And after I pick myself up, because the sound comes way after the explosive, I'm smashed down on the floor, I've got up, and as I'm looking around, all these fir trees in the back, it's like a Mexican wave with a blast wave going away, going down flat and then coming back up. So that explosion was quite something. Right, one of the other things that we do within the confines of DCs and maintaining things, if you look at the topmost video clip, we are no different to anybody else. We've realised that there is also a place for a containerised solution of a DC. So we make a container solution, we make a modular container solution. We do basic solutions, which are, in old terms and old terminology, a 20-foot and a 40-foot container with the equipment in. They can come pre-built, pre-configured. So you have the ability to put in, they're saying 7 racks. We can get more at a push. You can put all sorts of power generation, cold aisle, fire suppression. Anything and everything can be integrated and pre-built into a container where all you've got to do is connect power and data to it and then incorporate your servers into the solution.
Do you rent that? Do you work with companies that rent it on your behalf?
We work with companies that rent it on our behalf. We also sell it. We do. One of the things I should say as well is the fact that we are part of the energy efficiency group of Germany, whereby everything has a green standard. So we will take things back and recycle their componentry parts. So the panels, for instance, are composite panels. They're not made of asbestos and things like that. It's part of the space age tile that's used on the shuttle, or was used on the shuttle, I should say. So thermally, they are very good, as well as being fire protected, etc.
What sort of price are you talking about for data center containers?
DC containers can vary so much in the requirement because it's based around power, it's based around cooling, and the whole solution is very difficult to quantify. I can give you an example, but only a rough example. What you see here is a 6-meter container. We do it any size. The other thing to note, which you'll see in a minute, is that we can actually bay them together to make a bigger center, or we can stack them. Yeah, so if there is limited space, you can actually stack one on top of the other. So you could have DC in the bottom, facilities on the next level, chiller on the top if you so wish. Okay, an 8-meter container with 8 racks, high density cooling with a cold aisle, fire suppression, UPS, which is 120 kVA, along with monitoring, etc. within it, came out for a project at ABST in Spain at 230,000. Okay, but it does purely, it's down to the exact requirement. So if you gave, the other thing to note as well is, if you only want the container and you don't want anything else, you can have the container. We do this, the old shopping trolley thing, yeah? So we get a shopping trolley at this end, yeah, I'll chuck the container in, we go along, or cooling, or whatever else I want to throw in, and away you go. So you can do all sorts of variations on a theme. If we click on the bottom one, if it will work, now we've lost the mouse, now we've got it back. What you will see shortly, well, instead of me talking, if you look, this is a slightly bigger configuration, but if you look, it's actually stacked.
What sort of lifespan do you give these?
Depending on what you're looking for. If you go down the basic container route, minimum 25 years. But if you go down the route of a fire-protected cell, obviously the fire protection that's built within the confines of the unit has a degenerative period in it. So then it comes back down to 15. Now we do variations on a theme. So you can mix and match with fire rating, security. It also depends on where it's going. So if you went into a hot country, these are distributed throughout the world. So if it went to a hot country, then you have a solar shield. We can have solar windproofing. We go down the lines of geothermal cooling. Yeah? Well, yeah, but not so much. That's more heating rather than cooling. We do geothermal cooling for the hot countries, your Kuwaits and Saudis and places like that, where obviously the ground way below is a lot cooler than up above, so we can use that cooling medium.
So we do it for the Qatar World Cup then?
They are actually doing some work for them on that, not necessarily around the same thing, but similar. One of the things I didn't cut across as well is that we also use a CHP. We're into CHP now in a big way, which is cogeneration, heat and power. So we're looking at the possibilities, and we actually have systems that work now whereby we have easily reusable fuel supplies along the lines of rapeseed oil, palm oil, soya. We also do things along hydrogen cell, methane. We mix and match different, depending on where it is in the world, we'll mix and match what solution best suits the environment for the best thing to keep it going. We're also looking, as we discussed earlier, about the fact if you think about normal DC, is that you spend an awful lot of money, as we said, powering it up, which then generates heat, and then we spend an awful lot of money cooling it down. We also do lots of work with regeneration of that heat production. We're explaining the fact that one of the locations we work on, we've actually recycled the heat into radiators around the site. So the heat that's actually being generated is being reused, making us more efficient. What you see here is a basic container. This is the slightly older version. This actually is what they used to call an R20D. We've got rid of all that, ignore it. This actually just shows you a few pieces of it. There's an overpressure slide. So if you had we do a fire suppression system for the container, or we do a fire suppression system for a 1U platform for the racks. So we can do mix and match security with protection depending on what is your preference. The 1U platform system is normally Novec 1230, which if you've ever seen it is liquid until it hits the atmosphere and then is gas. Yeah? So the reason for it being in such a small platform is liquid can be put into a much flatter platform. If you go with gas, you have to have it to give it a clout to get it out. Fire suppressant normally, you've normally only got 8% of the mix of a cylinder is actually fire suppressant. The rest is propellant to ping it out into the space. Whereas the beauty of the Novec system is the fact that you can do it in a much smaller cartridged area. So a 47U rack, you can actually cover with a 1U platform system. But we'll do anything. Within the confines of fire suppression, you can have your Inogens, your Argons, your FM200s, Novecs, Proinex. We also do all the water mist systems that go within these. I think that the whole reason for us being here today is really the fact of just showing you that we are not, if you like, still our one-trick pony of being a rack manufacturer. We're more of a systems provider now. This obviously incorporates Rittal direct free cooling, the internals of the unit. This is our direct free cooling, but you can have high density cooling instead. Power distribution, PMCs, DTACs, monitoring. We were talking earlier about operational efficiencies. This is just trying to give you some basic information based around our free cooling system, which we use both with chillers where necessary and our standard cooling systems. If you look at the bottom, we're quite near the bottom on this. What we are tending to use now as well is to assist in our cooling procedures, we use a monitoring system which is evaluating the heat generation in a rack. So basically our higher cooling solutions are based around 6 EC fans, so variable speed. And the beauty of the monitoring system is it's analysing the air all the way down, up and down the rack. It takes in that information and then it will speed the relevant fans up or slow them down as is necessary. It's also the fact that the fans are hot swappable, so it makes life a little bit more interesting. Now, I did briefly speak about CHP, which you can now see. We can make a fully, if you like, automatic DC standalone. So, by having these two units put together, you can generate power, supply cooling to a condenser, and then into the unit itself. So we have autonomous power and cooling supply, redundant and eco-friendly power supplies. It's a turnkey solution. We'll come out of that because it won't let me play. Right, unfortunately, or fortunately for you, I should say, we choose innovation, as they say. So thank you for your time, but as we've got a little bit spare, because I'll probably zip through it exceptionally quick, do you have any questions? Yes, was that when can I go home?
No, close it up tight enough to like chop off the
Cables.
cables.
Yep.
How easy is that to restore once that's happened, basically? So if there's been a fire, how easy is it to restore your...
Okay, it's because that's doomsday scenario. Effectively, you've got to rewire back up to that point. So, if you can imagine, I think the easiest analogy is that, you know, in Buntsfield, when Buntsfield went up, yeah, right. So, DC's right by the side of it. You would have had a knock-on effect from gases and all sorts of nasties floating about. Effectively, what it will do is if the fire is right on it, it will react and chop those cables. But if it's as bad as that, then you'll be redoing all the rest of the structure anyway. But what it does mean is the servers and the equipment that were at the other side of that wall will be secure. Now, I'm not saying, what we're saying effectively is that in 1050 degrees C, for a set amount of time, this unit will stay in position and be okay. If you had something along the lines of, tragically, in America where the planes hit the Twin Towers, that actually generated 3,000 degrees of heat, but for a very short space of time. And now I'm not going to say that our room would have withstood that, but it would certainly have given it a much better shout of withstanding it. Now, as I say, we can build these around any environment as well, our modular rooms. So if you had columns, we wrap around the columns and bring them all up to speed as well. I mean, we do variations as well on the theme, I should say, with the fire suppression materials. We do the Roxtec module, which is top end. We do a thing called a rubberized, fire-impregnated mat. And basically, it's like a real sticky, horrible pad about so big. You slice it down the middle, shove the cables through, squeeze it back, and it just sucks to the cables. And then we put a fire paste around that. That's only a 30-minute solution. So depending on what you want and where you are, we can do all sorts of variations on a theme. Anybody anything else? No? No?
Thank you very much.
Had enough? Coffee's free somewhere. Oh, sorry.
Question, the enclosures, how efficient is the actual system running then? You know, the IT systems that are running in the enclosures. Obviously you're stifling airflow, aren't you?
No. No, because you've got a fan internally which is maintaining the airflow round. If you're on about stagnant air, then that air change is only done when you open the door. What you're doing is you're making a sealed environment, effectively.
Okay, so you're circulating the same air all the time.
Yeah.
Heating it up through the servers, cooling it through the top.
Yeah. Well, actually the unit goes on the side, but I'm being pedantic. I do apologise. Basically, yeah, it's a closed environment. If you think about it, the unit's only going to be fire rated if we can close off all the gaps. Yeah? So all you're doing is heat, it's recycling the heat.
Yeah.
And that's all. But you can do it in several different ways. We've got lots of variations on a theme within the cooling medium. So we can either have the heat rejection on a unit which just throws it out outside of the cell, or you can have an external condenser and do it that way, or you can have a chiller and do it that way. Yeah, so the solution, I can give you an example actually. I've just recently finished a project for Exeter University. Okay, and what they're doing there, at the moment they're going through a £22.5 million upgrade of the services for the whole campus. But what they've decided is that the students, like the gentleman here, yawning, I don't blame him, okay, the students switch off, yeah? Is it my turn for my tutor to turn up? No, I can't be bothered, you know. So what they've done is that the university have been very clever in the fact that they're now putting a data pod on the top of every residential building and lab, okay? And what that does is they're putting fibre optics into it, and they're running it down like into all of the offices and everywhere across the site. You know, like you walk up to a bus and it says number 369 to Bristol is coming in 5 minutes. This says Professor so-and-so's thing is on in 2 minutes in this hall. And that's what they've done. So what I've done there is I've actually made them a fireproof cell that this communications block is going to go on the roof of every building. Yeah? And we work down a similar route. It's generating heat, we reject the heat outside, and we're using free cooling in that instance. But you can do lots of variations on the theme. So, you know. Right, I've now bored you all to death. Thank you very much indeed for your time.
Thank you for yours.